looking at the phosphate ions. Now, there is a couple of different ways you can do this, because when you're looking at excess, because this is like the excess part of the problem, the sodium phosphate was one of the original reactants. Let's write that reaction back up here. So looking here, we need to go back to the original equation. We had our sodium phosphate plus our, was it lead 2 nitrate, giving us our lead 2 sulfate, phosphate, which is the solid, and our sodium nitrate. And we needed to have this balance. This was 6, this was a 3, this was a 2, right? Okay. So we have our original balanced equation because this is solution choice, so we do need to know the molar relationship between the reactants and products. But we figured out that the lead 2 nitrate, this was our what? That was the limiting reactant. Good. This was our limiting reactant. That means over here, this is going to be the excess. So when we're looking at concentration of phosphate ions, this one is part of the excess. So not all of the phosphates are going to get used up and fall to the bottom and to precipitate. We have to figure out how much is left over floating around in the water and then divide it by the new volume to get its concentration. So the way I work these, and you can do a couple different ways, but the way I work these is I always figure out my starting amount, subtract it from my amount that was used to get my leftover amount. So that's the process I use. So if we're starting with 0.0100 liters, okay, this is 0.30 moles per 1 liter of our sodium phosphate. 1 mole of sodium phosphate equals 1 mole of our phosphate ion, right? This is how much phosphate we're starting with, okay? This is the starting amount before the reaction occurred, okay? So that ends up being what? 0.0030 moles phosphate. Somebody check that, calculate that. Okay. So that's the first part, figuring out the starting amount of the moles. Now we have to figure out how many of the moles were used. This is the harder part. How do I work that? Where do I start? From the previous part of the problem, how much of the mass was produced of the precipitate? 1.1 grams was produced of the lead 2 phosphate, correct? Can't I work that to the phosphate ion to figure out how much of the phosphate was used? Can I do a stoichiometry problem like that? Sure can. So let's do that. And it's nice and convenient because we already know the molar mass is that equals 1 mole of Pb3. Okay. Now in 1 mole of our lead 2 phosphate, how many phosphate ions do we get? 2 moles of our phosphate, right? Because of this 2 there. So every time that breaks apart, it's going to put 2 in there, or 2 need to be in there. So what do we get here? How many moles? This is the moles used up. That's what we're getting here in the reaction. Right? This is the moles used up of the phosphates. So far, are you tracking with me? Now, it's a simple subtraction problem here. So we're going to take our starting moles, subtract the used amount, and that should give us our leftover amount. So this is 0.0030. Now the only thing left to do is to do what? Divided by the new volume, and our new volume is, new volume was 30 milliliters, right? We added 10 plus 20 nickel. Alright, those were put together, so this is 0.030 liters. So what is our final molarity for our I guess we're waiting to round to the very end to the correct number of 6 bigs, going with 2. So I think all the measurements were 3 or 2 in the problem, so we're going to have 2 in our final answer. Don't forget your unit, substance. Always important to add on to the end there. Alright, calculating the mass of the solid. That concept check 1 was multiple steps. That's more of what you're going to see for a free response, just so you know. Multiple step problem like that where they tack on an A, a B, a C, a D point to it. This one, however, just a quick straight up solutions choice problem. So take a look at it. See if you can figure out maybe where to start. You're calculating the mass of sodium chloride. Must be added to the silver nitrate to precipitate out all the silver ions. So what's the precipitate going to be? AgCl. We know that's one of the exceptions to the chloride solubility rule. So you're looking at that. What did you always start with writing out first? The balanced equation with the formula, so you know the molar relationship. So here is our precipitate. So we need to know how many moles of our silver that we're starting with to work it to figuring out how many grams of sodium chloride to put in. So we have 1.5 liter of 0.1. Start there. It's going to build up basically one big long track. Now that I'm at moles of AgNO3, what can I go to? 1 mole of AgNO3 is going to equal 1 mole of NaCl. Since I want the total solid mass, I'm going to have to work at 2 NaCl. Then 1 mole of NaCl is equal to how many grams of NaCl? What's the molar mass of NaCl? 58.44. Okay, so this one, not as long as the concept check one. Just got to start thinking, okay, silver is 1 mole, the chlorides are 1 mole. I can work it stoichiometry-wise using my balanced equation. Everything in here is 1-to-1, and I can work my way to the mass. And in a lot of these problems, as I've stated before, you have no idea where else to begin. Write out the balanced equation and change it to moles. It's always a good starting off point. So what do we get here? How many grams? 8.77. Unit, substance, don't forget those. And you can always check your work too by canceling your labels, liters with liters. Moles of the AgNO3 with moles of the AgNO3. Moles of the NaCl should cancel with the moles of the NaCl, and then you're left with your grams. So it's always good to check your labeling. They should be able to cancel. Looking at exercise 11. What are we going to do here? Aqueous solutions of sodium sulfate and lead 2 nitrate are mixed, and you get lead 2 sulfate precipitating. Calculate the mass of the lead 2 sulfate formed. And now they're giving you values for the lead 2 nitrate and for the sodium sulfate. When they give you both reactants, what does that tell you to do? It is a limiting reactant problem. You're going to need to work both. Figure out which one comes out less so that you know your theoretical yield. This one right here comes out less. So this one is going to be the mass produced. And this is also your theoretical yield. Good? So we were looking for the mass of the PbSO4, and that was going to be 15.2, because out of the two, the one that comes out less is the mass produced, or the theoretical yield.